In the previous video, we have created some logic for our enemies that they will start moving to the right, and one will kill our own agent, and the second one will simply make a move. In this video, I want to first improve the way we perceive the enemy movement, because right now they simply move. I would want them to flash and later on to have a red outline. And we are going to implement the code that the enemy not only moves to the right, but also select a random position where they want to perform the movement. So let's get started. First of all, let's focus on improving the visual side of things. So I'm going to select the hierarchy, select one of the enemy warriors. This is a prefab variant, and I think in one of the previous videos I have removed this flash feedback script from this enemy. If we select this, and if we select a remove component, then we have option to revert it. So now this should be reverted. So if we go back, if we try playing, we still shouldn't be able to select our enemy, as you can see, but now we are going to be able to make it flash. And how are we going to do this? Well, we need to go to our scripts. Let's select our enemies folder, and we are going to select basic enemy AI script. Let's open it up. Okay, let's create a serialized field, and we are going to type private, and this will be flash feedback, and this will be flash feedback or selection feedback. Okay, so now all we need to do is assign it through the inspector, or we could get it, so we could type in the awake selection feedback equals get component, and we could ask for the flash feedback. And now when we start a turn, we want to, after we debug.log statement, we can type selection feedback.play feedback, I think, yeah. And when we finish our movement, so this would be in the move unit coroutine. When we have a path, we start another coroutine. When we do not have any more points on our path, we should call turn finished invoke, and we should also call this when we have this first check, as well as we should have our selection feedback stop feedback. And now, not to duplicate the code, let's select those two lines and right click here, quick actions, and extract this method. So let's call it finish turn or finish movement. Okay, so we are going to call this method instead of this turn finished at the bottom of our move unit method. So now we are sure that we call the same logic in both of those places. Okay, great. So this should stop our selection feedback, so flash feedback, and when we start our turn, the enemy will be flashing. Let's save it, let's go back to Unity. Great. So here I am in the game that is now playing. I will press this next turn, and as you can see, our enemy is flashing. And when they finish their turn, they stop flashing, so it is much more clear what is going on, which enemy is performing a move. Of course, you can increase the times for waiting before the enemy is taking the step forward or starting to attack, but basically this is the logic behind it. Now we can go back to our basic enemy AI script. Great, because at the bottom we had this get path random position, get path to random position, where we have currently debug.logged and return a list that we have created by hand, but I want to turn it into an automated process. Okay, so here instead of those two lines, I'm going to paste the logic that we are going to use. So first, we are going to have a list of vectors to int possible destinations. This will be basically the same logic that we have used in our character movement. So movement range keys to list to get only this part, the keys of our dictionary. So those are all the positions that we can move on top of. Now, of course, this will contain a starting position. So before we select a random position, we may want to create something like possible destinations remove. So we want to remove from our list a vector to round to int transform.position. So this should remove from this list the current position that our enemy is on, so that it will prevent our enemy staying in place. So now when it is done, what we want to do is we want to select vector to int selected destination equals our possible destinations, and we are going to use Unity engine in the square brackets random range, and we are going to select a random range between 0 and possible destinations dot count, so the length of our possible destinations. And the range method, it has this max position exclusive, so we can only get from 0 to this -1 basically, so we do not have to worry about any exceptions being thrown. And last thing that we want to do is we want to get the list of vector to ints, a list to return. So basically this will be our path to return to our coroutine. And to do this we are going to need to have a separate method called getPath2. We are going to pass the selected destination, so the destination to which we want to travel, and our movement range, so our dictionary. So if you have this all typed, all we need to do is right click on this getPath2, quick actions, and let's generate this method, and we are going to implement it to give us the path. So let's change the name of the getPath2 vector to int selected destination to simply destination. Okay, and the second parameter of course is our dictionary movement range. Okay, let me paste the code that we are going to use. So first we are going to create a list vector to int path equals a new list of vector to int. And we are going to add to our path the destination, because of course this is where we want to go. And we are going to create a while loop. While movement range destination is not equal null, because as you might recall, our first position, so our starting position in our dictionary has the second value, so this vector to int with the question mark, equals to null because our start position has no parent position. So this while loop will stop when we reach this position. But since we are starting from the end, so from the destination of our path, we are going to access path, add movement range, and since for our destination we have the parent tile from which we came to this destination tile. So this is what we are adding here. So from our destination to go back to our start position, we need to go to the movement range destination value, which is the previous tile on our path. Next, we are going to assign to our destination, because we can reuse this variable, we are going to assign to it a movement range destination value, so the previous tile from which we came to this destination tile, and we are going to return to this while loop. And again, if the new destination, so the previous tile, has value equals null, so if we only want to do one step from our start position, then this loop will end. If not, then again we are going to add to our path, and then we need to reverse our path because we have started from the destination. So our first position is the destination. If we reverse it, we are going to have this correct path. But now, first tile on our path will be our start position, and we already are on our start position. So we want to return path, and we are going to use link library method skip. So we skip one position from our list, and we convert it to the list, because link uses IEnumerable, and we need to convert it to a list to return it in our getPath2 method. So now we have all the positions from the next tile from our starting position up until the destination to which we want to go. And this is how we would find a path using the result of our breadth first search. So now we have returned this path to our get to random position, so this is our path, and now our enemy agents should complete their path to the random position, not only in the right direction. So let's save our script and let's go back to Unity. Okay, I don't think that we need to change anything in the editor, so let's press play. Okay, and now if we click next turn, we should see that our enemy travels to the random position. So this enemy moved to the left and downwards, and this one moved to the right and then wanted to go downwards, and since there was our player, it simply killed our player. And that's basically it. So now what remains is to make sure that our enemy stands out from the player agents. So we will start in the next video to create a custom shader using Universal Rendering Pipeline. So let me mention how to set up the Universal Rendering Pipeline that we are going to use for our shader. If you go to your window, Package Manager, a new window should appear somewhere, and it will show you all the packages that you have in your project. If you select in the top left corner Unity registry and you type URP, or I think the Universal Rendering Pipeline, okay, you will see this Universal RP, and I have it installed, so you need to click install and you will have it. So let's close the package manager, and now in our assets we need to right click, and I have this URP folder, so we need to right click, create, and we will have in the middle somewhere the rendering, and you will find Universal Rendering Pipeline, and you will want to create the pipeline asset 2D renderer, and it will create for you the Universal Render Pipeline Asset 1 and Universal Render Pipeline Asset 1 renderer, and this will be your asset that you need to now assign. And to assign it, you need to select Edit and Project Settings, and a new window should open for you. And in the project settings, in the quality, we need to select Rendering. None is the built-in rendering pipeline, so you need to click this, and you will find your Universal Rendering Pipeline Asset 1. Now, in case your materials or your screen goes pink, all you need to do is select Edit and Rendering Pipeline and Universal Rendering Pipeline, and there should be Upgrade Project Materials to Universal RP Materials. Proceed, and I think we have selected wrong one because there is now, I think, for 2D, Upgrade Project Materials to 2D. And proceed, and all your pink materials should go back to the default color. So now that we know that our project is using the Universal Rendering Pipeline, the scriptable pipeline, we can in the next video start creating our shader. Thanks a lot for watching. If you have enjoyed this video, keep in mind to leave a like, leave a comment, it really helps me a lot with YouTube algorithm. Subscribe to the channel if you haven't done it so far, and I will see you in the next video. Take care!